We have some people here in the Blake Library. Can you guys hear me okay? Perfect, perfect. So welcome to our latest Water Ambassador Lunch and Learn webinar. This is brought to you by both Martin County and UF-IFAS Extension and Florida Sea Grant. So we just have a short introduction and then we will get started. I just gotta, there we go. Move some windows around. And so we do this every third Tuesday at noon. And we are fortunate also to thank you everybody for joining us online. We also live stream this in the Blake Library in Martin County in the auditorium here. So if you ever want to join us in person, like we have people here, welcome, thank you. And these are our remaining webinars. We have two more, September 13th on manatee habitat restoration funding projects. And then on September 27th, we're gonna have someone present about the Indian River Lagoon bottle cap project. So that sounds a little esoteric, but trust us, it's about improving water quality in the Indian River Lagoon. All right, so, and then we will post the links for each of these webinars, the remaining two webinars in the chat as we go along. So just a little bit of housekeeping here. We've got, we ask, everybody should be muted online when you join. And if you, let me see, if you don't know how to do it, just look for this little microphone symbol and you can select that to mute yourself. And if you are connected to audio and can't hear us, if you see that green arrow pointing to that little caret, you can click that and then you can adjust your audio settings. And we do ask that you turn off your video online because it does help with the bandwidth and being able to view the slideshow. When we get back into questions, if we have any questions as we go along, it's okay. I think it should be okay by then to turn it back on. But we do ask during the presentation that you keep your video off. This just makes things run a little bit smoother for you anyway. So you can look at whoever's here. I think we have a pretty healthy number of people today. And then again, the important part is the chat. Let me see if I can get my arrow. There we go. If you can see that. So click on the chat and you can ask questions anytime during the presentation, but we will address the questions at the end of the presentation. And then whenever you need to leave, go ahead and click this leave meeting button right there. So let me get back here. And then you can also change your view settings. You move the speaker windows around if you want to, and so that you can play around with that as well. And this webinar is being recorded and will be available online. We will post that link in the chat as well. But yeah, please visit that website because we do have all of our past webinars posted on that page as well. So and we tend to get a lot of people that register and then watch the recordings later. But if you haven't seen any before, highly recommend it. There's some great topics this year, and then I think we have almost all of last year's posted as well. And again, as I mentioned before, please use the chat feature to ask your questions. You can enter it in anytime. And we will address them at the end of the talk. So with that, we'd like to introduce our next speaker. Our speaker is Mr. Nicholas Muzia. He is an engineer and he is the infrastructure manager for Martin County Public Works. He manages multiple field crews and is a project manager for a wide variety of county projects, including a stormwater master plan for local historical drainage basins and stormwater treatment areas, and resiliency retrofits and shoreline armoring and basically making Martin County infrastructure safe for things like storms and sea level rise and flooding as well. Nick has a passion for the natural environment. And the reason why we invited him to be a speaker is because he's doing some really interesting work trying to find natural solutions that can be incorporated into existing stormwater infrastructure that not only improve water quality by, say, taking up excess nutrients, but also providing habitat for wildlife within those structures. So we're really excited about to hear what he's got for us today. He is a FAU, a Florida Atlantic University alumnus with a degree in ocean engineering, and he's a Martin County resident, I think, as well. Is that correct, Nick? And so you can find him, just like a lot of us like to do, just enjoying the coastal environment the beautiful coastal environment that we have here. So with that, Nick, I will relinquish control of the stream to you. And thank you, everybody, for joining us.
All right. Can everyone see the intro slide here?
Yeah, looks great.
All right, awesome. Move a couple things over. All right, so thank you very much, Vince, for the introduction. So again, as you said, my name is Nick Muzia. I'm the infrastructure maintenance manager for Martin County. So I oversee a whole lot of things, roadways, drainage, and a lot of that. So this presentation here is one that I gave to Florida Stormwater Association. Kind of this past year, that was pretty interesting concept that we're doing. But I want to start it off with a quote from Albert Einstein that says, "We can't solve problems with the same kind of thinking we used when we created them." So just think about that kind of as we go along a little bit. Let's see, is it? So yeah, as I said, some of the background. So we did a pilot project in Martin County in 2020, and we presented the results at the Florida Stormwater Association annual conference. We're going to talk about stormwater maintenance and its relationship between water quality and vegetation in Florida. We're also going to learn a little bit about a new best management practice, or BMP, as it's referred to. And down here is a link. You can also visit floridadep.gov for more info on what BMPs are if you're not familiar with that as far as managing stormwater. So we're going to start off with vegetation. So one component of what I'm involved in, and especially in Florida, is vegetation. Everything grows down here, and vegetation requires a lot of maintenance. When it relates to stormwater, it also impacts flood control, and it's commonly perceived as being a nuisance for flood control. You can see one of the images here is of a canal inundated with water lettuce. That's not very good for the aquatic environment in that location, as well as for drainage. So maintenance is also costly and constant. So Martin County spends well over $1 million a year to maintain vegetation. There's even a defined nuisance vegetation defined in state statutes. That's a noxious weed or any plant that's highly destructive, competitive, or difficult to control. So, we looked at that and said, hey, we need smarter solutions. So smart solutions, they're not always obvious. Everybody's got their thought on how something is, but factor in many different aspects, and then you can start to develop your smart solutions. They get pretty complex at times. So in order to develop smart solutions, we need the right tools. So as a stormwater manager in Florida and most part of the country, it was originally governed by the backbone was set in place by the Federal Clean Water Act in 1972 that kind of outlined what we need to do with runoff. And then Florida has very specific controls, and a lot of them as they relate to vegetation management is the Florida Aquatic Weed Control Act, Aquatic Plant Management Act, And then also statute 373 for management and storage of surface water. So a lot of these state statutes govern why and how FWC and other entities, local municipalities maintain vegetation. There's also Florida rules for water quality. There's a state water quality standards, and the TMDLs are total maximum daily loads, which are set based on each basin for nutrient impairments such as nitrogen, phosphorus. So maintaining vegetation. So as a stormwater manager, this is the most common concern or complaint I get from the public is, I got weeds growing in my ditch. How can you get these out of here so that I don't flood? So how do we do that? Through either mechanical or chemical treatment. So the photos on the right side here is a boom mower. In essence, it mows the grass with a large boom, or we use excavators as well as hand crews with weed whackers and ditches. Weed whackers go into the ditches and maintain them and keep them clean. So Martin County alone, not a huge county, has approximately 450 miles of ditches and swales that we maintain for vegetation. Dealing with erosion. This is a common thing with drainage features. It has a risk to damage property. It impacts water quality. The sediment that comes from erosion moves downstream. It also impacts flood control and maintenance. It's also costly to maintain. So a lot of times when there's erosion in an area, it's pretty expensive to get back there and do that work. Then we have to balance upholding state water quality. Especially everybody here on this webinar all has a special place in their heart for water quality, as do I. So we've got to meet these state requirements and BMAP targets. Like I said earlier, there's the TMDLs, or the total maximum daily loads for nutrient pollution into some of our water bodies. New infrastructure, such as the picture on the right here is construction of a new stormwater treatment area, is extremely expensive, especially nowadays. With the real estate prices in Florida, just acquiring the land to build new projects is almost impossible. Can we be more cost effective? Are there more cost effective ways to help balance our nutrients, pollution, and mitigate erosion? So I just real quickly went over a complex problem that is a little bit more difficult than just mowing the lawn. So you have project costs. Or can it be built? What's your project idea? Now, what does that project cost? Is it actually maintainable? And what's the sustainability of it? Then, is it environmentally responsible? Also, is it publicly acceptable? Then do you have the available funding to do what you want to do? And it's this constant cycle that we're trying to balance here as managers of infrastructure. So how do we solve this problem? So I just talked a little bit about vegetation and some of that. So I got some ideas. Robots. That's right. I'm sure everyone here has a robot that cleans or sweeps their floor. I do. But is this cost effective? What's the public opinion of a robot walking through the, through a ditch or through the property to help try to maintain these areas? Another means, chemical spraying. All of us here understand and probably read the headlines and know the public opinion and bad press that goes with chemical spraying of, Florida's fight on chemical herbicides. Florida's manatees face new threat, weed killer. These are environmentally concerning, but from a maintenance standpoint, it's extremely cost effective, and that's why it's done in locations. Industrial solutions, concrete, large ditches, gray infrastructure, as it's commonly referred to. Expensive, not natural, limited to no treatment, not looked at as environmentally responsible. Now, natural solutions is a term that's being talked a lot about lately. What would Mother Nature want? She'd probably want a natural solution. But also, from a manager standpoint, what do grant agencies want? Some of these are terms and definitions from FEMA's BRIC grant. Water resource projects utilizing natural and engineered processes to create multifunctional infrastructure. According to FEMA, nature-based solutions are sustainable planning, design, environmental management, and engineering practices that weave natural features or processes into the built environment to promote adaptation and resilience. Right now, this sounds like a no-brainer. This is the way we want to go, right? Florida DEP has recently launched a green infrastructure initiative aimed at communicating where green infrastructure can be incorporated and what people can do. I think one of the biggest things is just communicating that. And that's one of the reasons why I'm here. And I think this is such a great idea to kind of talk about one of many different solutions that we can go about to solve these problems. FEMA's BRIC grant, or Building Resilient Infrastructures and Communities, recently has a technical evaluation criteria of 10% of the application score for incorporating nature-based solutions. So this becomes very appealing from a grant perspective, which is great for me. So, but what if, so we talked about natural solutions, and what if Mother Nature already solved this problem for us? For like the one I mentioned before, weed control, erosion, and water quality. What if that was beneficial submerged aquatic vegetation? So I'm going to talk a little bit here about a pilot project that we did in Martin County. We planted in 2020 called the Coral Gardens Beneficial Submerged Aquatic Pilot Project in a stormwater treatment area, a lake of about 5 acres, located in one of the largest urban basins of about 3,000 acres in Martin County. So why did we do it? Well, I had originally looked at this because Martin County spends on every couple of years about $150,000 to dig sandbars out of our lakes. Because with stream functions, as water is moving in a ditch quickly, as soon as it hits a wide body of water like a lake or a river, the velocity slows down and then sediment deposits out and it creates sandbars. So we spend $150,000 every couple of years to dig sandbars out of our stormwater treatment areas. So we said, hey, could we find a solution that can reduce sediment transport by stabilizing the channel bottoms? Could there also be a beneficial use for water quality and environmental restoration? Also, we wanted to try to see if it had the ability to outcompete nuisance submerged aquatic vegetation, such as hydrilla, which is a common aquarium plant, but it grows in 30-foot long legs and breaks off in huge mats that clog up stormwater infrastructure. So this is probably the culprit. In the stormwater world, it would be like the native lands version of Brazilian pepper. So could we use something to possibly outcompete the hydrilla that we have to either treat chemically or remove mechanically? So how do we do it? So with this project, we planted American eelgrass plugs, just like what's shown here in the hand. We planted about 2,000 to 2,500 eelgrass plugs in a couple different areas within the stormwater treatment area. Some of those areas were where we expected fast-moving water. Some of it was where we expected slow-moving water, and then into the STA itself, where water is visibly not moving. We selected the location specifically based on downstream controls. We didn't want them to affect drainage or a perceived impression of, hey, that's going to block my drainage. So right now we have the area most controlled is downstream of the control structure. So the control structure in a drainage project is like a weir or sheet pile wall with a notch in it, or a concrete structure with a notch or a window, and that's meant to control the amount of water that can move through there. So that's important when it comes to designing and how a lake or a stormwater feature functions, how much water it can let out. So the lakes are meant to collect a lot of water and then let it out at a slower controlled rate. So right now we have this project on the downstream side of our control structure. We also kind of selectively internally, after this was done, we met with our ecosystems management group and kind of came up with a couple of other areas that were selections based off of feeding into the Indian River Lagoon, St. Lucie estuary, which are all impaired and important local water bodies. As part of this, we wanted a steady flow of water because eelgrass does better when the water is moving. And we picked some of these locations because they make a good, what I call last line of defense when it comes to stormwater and pollution control. This is the point where water leaves a municipal stormwater system and goes into its receiving water body. In this case, into the St. Lucie estuary. So we had some project partners with this one. A local environmental consulting firm, Ecological Associates, Inc. was our monitoring firm, and Sea and Shoreline Aquatic Restoration was a nursery, but this project was funded entirely from Martin County Board of County Commissioners. What we learned, so this is where it starts to get interesting from a scientific perspective as well. So we did quarterly monitoring and found that eelgrass really loves moving water. It grew and spread the fastest when the water was moving the fastest in the inflow ditch. In about 6 months, we noticed significant growth there. We also learned that predation was a major factor in success. So everything, the biologists on the nursery side will tell me everything eats this, from turtles, snails, ducks, fish, absolutely everything. The moving water, we think, benefited the eelgrass because turtles and ducks were less likely to establish, to sit and eat the eelgrass. So that's where we learned that it would establish the first. It did show that it had the ability to compete with nuisance submerged aquatic vegetation. It took about 1 to 2 years to actually establish and see results of the project. So like I said, we planted this in 2020, but really about a year later was when we started to see the fruits of what we had done. It does require limited maintenance for establishment. We estimate that about 80 hours of maintenance annually per like small project site. So the hydrilla, as you'll see in the photo in the lower right, there is some hydrilla growing up through that, which can be a problem. So that required mechanical maintenance. In essence, a person with a potato rake to reach out there and grab that, because the hydrilla will grow in 30-foot long branches and actually blanket out the eelgrass. So the eelgrass competed very well horizontally with the hydrilla and other nuisance vegetation that we were trying to control, but it couldn't compete vertically because the hydrilla would grow over the top of it and shade it out. So we still had to maintain that. But after you got an eelgrass bed established, it became much more cost effective to maintain that simply by mechanical labor. We also found that it enhanced water quality, which to the scientists and biologists in the room is probably a duh. We understand that, but actually collecting that data, and I'll go over a couple of bits in the next steps on how we can relay that to the state and really work together to take this to the next level. So we had, over the course of 2 years, and it's still going on, kind of monitoring, tracking of growth rates in some of the areas, and you'll see how it's done with some quadrats over a transect in a couple of areas. So we started looking at the water quality in March and April. We set up a little test area where we sampled the water within the lake, immediately downstream of the control as it was leaving the lake, and then just 200 feet downstream of our well-established eelgrass bed. There was no other water coming in, no water leaving. So it's just a controlled area of just 200 feet of established and maintained eelgrass bed. Some of the reductions we got, if anyone in here is familiar with pollutant reductions for other BMPs or best management practices, this is pretty good. So we got 30 to 40% total nitrogen reduction and over 40% phosphorus reduction. Huge reductions in E. coli, suspended solids. So to put it in perspective, a total phosphorus reduction of 40% or nitrogen of 40% is typically what a $4 to $5 million stormwater treatment area will get you based on residence time. But After 20 years, we've been finding that those stormwater treatment areas, due to a sediment accumulation, don't function as well as originally intended. So this is huge, all for a project cost of around $15,000. Compared to, as I stated, stormwater treatment area, build a new one, is on the order of $4 to upwards of $10 million. So here we found that we've got a pretty good cost savings. And the annual maintenance cost of about $1,500. So some of the next steps. So one of the things that we still have to do and are continuing to do is maintenance. We're maintaining manually the hydrilla and other plants in the area. We'd also like to plant more sites. So I'll talk a little bit at the end about how we can, we're going to be looking for volunteers. I've got my contact information out, but we'd like to partner with other groups to possibly find ways to plant more sites. We also need to collect additional data on water quality improvements. So that's something that Martin County is doing and actively plans to do more of here. One of the things that I think with this is this has a potential to be the most cost-effective stormwater BMP ever. Pretty bold statement, but I think it really does have that potential. So that's why we're out here communicating with everyone. Currently, this is listed in DEP's list of BMPs or best management practices, but it's shown as lacking data. So it doesn't actually have a defined nutrient reduction criteria for design. So what we'd really like to do is start to do more of this so that we can work with DEPs and our state partners to get this listed so that municipalities and other entities, private, can do projects like this and maintain them to get cost-effective nutrient reduction. So now we're going to get a little bit into the weeds, literally, on technical details of why this works. Because generally, stormwater and vegetation, from a stormwater management engineering standpoint, get rid of the vegetation because it slows down water movement. So vegetation impacts flood control. It's obvious. There's something I'll go over a little bit in here called the Manning coefficient that increases with the amount of vegetation in channels. And that's a parameter that engineers use when they're designing stormwater assets and just doing design work for stormwater. But could beneficial submerged aquatic vegetation, such as eelgrass, be the exception to this rule, and how? So we'll start off the Manning's equation. This is a common equation in the engineering world of stormwater that defines open channel flow. So it's also a modeling parameter when doing stormwater and watershed modeling, and it's based heavily off of the Manning roughness coefficient, which this equation is used to determine flow rate through a channel. Sediment transport. Sediment transport is a relationship between sediment size and the velocity of the stream. Sediment can either be eroding, transporting or moving, or depositing. There are several curves that illustrate that, the Hallstrom curve, the Shields diagram. We'll go over the Hallstrom curve next, just so you can get a better understanding. And sediment does impact water quality. As silt and everything are moved down, that's oftentimes what's carrying the nutrients. So this is the Hallstrom curve, which is a simplistic representation of erosion, but I think it'll work. So we have the three zones. Like I said, sediment can either deposit, transport, or erode. We'll take a 1/2-inch stone, for example. A 1/2-inch stone will start to erode. It'll get picked up in a stream at roughly a velocity of 3.5 feet per second. But it can remain moving through a stream at as low as about 1 foot per second. Anything below that, and it gets deposited or settles on the bottom. Sand. Sand is the most common substrate in Florida. Sand can actually be transported in as little velocity as 1 foot per second, which is pretty common in a stormwater system. We get that in the project site that we had in the inflow ditch on a regular basis. It's moving 1 foot per second. And silt, which commonly carries the nutrients, can transport in as little as 1/10 of a foot per second, which is barely visibly moving water. So that means that that nutrients is moving downstream if we see the water moving. Boundary layer theory. So this is a theory in fluid mechanics. It's the thin layer of fluid that separates where the velocity is 0 on the bottom or against a hard surface, and the peak velocity within the stream. So this is affected by the surface roughness and the fluid velocity or the speed. Like I said, where it changes from 0 to the speed of the moving water. So selecting a good location. So a project like this is definitely a right tool for the right job. So downstream controls are critical. And making sure that we're downstream of them if you're doing a large project is good. Considering the hydraulics of it is important as well. And part of the reason we picked our area was to avoid public opinion conflicts. Like I said, one of the most common complaints I get from the stormwater is these ditches and are overgrown and they need to be trimmed to improve water quality or trimmed to improve flood control. So here's a little image of a video of water moving over an eelgrass bed. So why is it a great idea? So in Florida, a lot of us here, especially in this webinar, all want clean water. So this is a good strategy tool that we can use and try to help communicate to other folks. So I had said, some of the other aspects of why it's a great idea. So increased residence time. So residence time is a term used in stormwater management that relates to how long a molecule of water rests within a given water body. The longer it sits, the more sediment and everything are going to precipitate out. So the eelgrass significantly increases residence time during base flow locations. So when the water is moving slowly and we're not concerned about flood control, it slows down the water and increases residence time, thus improving water quality. So a study by a gentleman, Dr. Harvey Harper, for DEP in 2007 evaluated it and said it's likely the most important factor for water quality performance. So the neat thing about the eelgrass is when water's moving slow and we're not worried about flood control, it slows down the water more and treats it better. Stabilizing the boundary layer. So with the eelgrass along the bottom, it actually increases that boundary layer so that the sediment doesn't get picked up and moved. So in essence, it widens it. It reduces erosion, improves water quality, and it can limit the nuisance vegetation such as hydrilla. So Manning roughness coefficient. So in the stormwater world, the Manning roughness coefficient is one number that's independent of velocity. So there's a term called flexible vegetation that I think is being talked about a little bit in the environmental engineering world that relates to flexible aquatic vegetation such as eelgrass. So for flexible vegetation, the vegetation height decreases with increases in velocity, and hence the velocity resistance decreases with flow velocity. Therefore, we get lower impacts to flood control when the water is moving faster. So the eelgrass or any other flexible vegetation actually decreases its drag when we need it to. So Mother Nature seems to have solved it already. She slows the water down when we don't need flood control to treat it, but when we do need flood control, she moves it faster with flexible vegetation. There's a study that I found, I did a little bit of looking, and really not a whole lot has been done in something similar to this, but there's a study done in 2019, published in 2020, that evaluated this. And they took a couple different areas and found that as the water was moving slowly, it significantly increased the Manning coefficient up to amount 0.3, which for anyone involved in stormwater design is significant. But once the stream velocity increased to 1/2 foot per second or more, it dropped greatly. Currently, the Manning coefficient is used on one number independent of stream velocity. So we think that this could be a game changer in how systems can be designed to incorporate natural solutions. So to sum this up in an illustration, picture A would be a boundary layer without vegetation on the bottom. Very thin, the velocity of the stream is very close to the bottom, and this is your greatest condition of erosion. In image B would be where you have submerged aquatic vegetation. That boundary layer grows, and that helps to stabilize the bottom, and you get less movement because your velocity near the bottom is less. And then in a flood control condition like image C, you're going to have faster moving water, and it's going to lay that grass down and actually reduce your drag coefficient to a Manning somewhere between 0.12 or 0.05 based on the study results. Also, why is this a great idea? It creates an improved ecosystem. So through this exercise as an engineer, I got to learn what a bryozone was, which is pretty much like a freshwater coral. But also in our area, we've seen blue crabs, shrimp, and much more. So submerged aquatic vegetation is a great idea for a stormwater system. This can be adaptable, and it's also quite inexpensive. You just have to select the right location, select the right plants, and make sure that you evaluate it for flood control. And that's what we're doing here in Martin County. Also, the maintenance practice needs to be changed. So some mechanical or manual maintenance needs to be done early on to help get it established. Also, it improves habitat and water quality and looks way better than the alternatives. So I want to finish this out with, if you're interested in helping out, I'm looking at getting some contact information from people to try to build more of a citizen science project to help us evaluate this and perform some of the maintenance as well, and do some plantings in the spring or summer. So currently we planted our first site in 2020, got our water quality results back, and then Martin County immediately funded the second one in Salerno Creek, where we planted some more salt tolerant American eelgrass, as well as the other type, which is a variety called Rockstar. And we also planted grass, Rupia maritima, or widgeon grass, which is one of the 7 Indian River Lagoon species in the Outfall Canal. And we're looking to continue to monitor that. And we had some volunteers help us out with the planting for that. So we're interested in trying to partner with other groups to do cool things and help us all get involved so that we can plant even more. So with that, I'll leave it to, if we have any questions, and my contact information is right there below. So feel free to reach out if you have any questions. Thank you.
Great. Thank you, Nick. And Vincent also put your email address in the chat box, so we'll have that. Everyone, now's the time to put your questions in the chat box. I'm going to launch the poll for you. And we do have one question to start you off with. So Stacy Cecil asks, she says she might have missed this, but how long was the study period for the SAV pilot where you were highlighting the water quality benefits? She's particularly interested in the nutrient components. And also, were the values pre-treatment at or lower than the state standards, or were they well above? Thank you. And that's in the chat if you need to look it over.
All right. So the study period, we did just two grab samples, or we used grab samples, but we did it in 2 instances, one in March of 2022 and the other in April of 2022. And the water leaving the STA was not meeting water quality standards, but as it ended the 200 feet of eelgrass, it did come within. So we looked at that as a huge success because of that pretty large numbers of nutrient removal.
Great, thank you. Vincent, do we have any live questions?
Yeah, no, not at this moment, but I did want to, I didn't address this earlier, but if anybody here in our live audience has any questions, feel free to ask, and I will repeat them over the microphone online. Also, I just wanted to add that both online and here in person, if you're interested in helping out with this project, you can reach directly out to Nick as he posted, as you can see on his slide there, but also feel free to reach out to Lisa and myself. As Florida Sea Grant agents, we do a lot of work in community citizen science projects, so we can also help Nick with that as well. So any questions? Yes. The eelgrass, it's a native species. It's Vallisneria americana. So what Nick has done is plant these in the stormwater treatment areas, but it does exist in nature as well. And it's particularly important in upstream freshwater to maybe very low salinity areas like the Caloosahatchee, for example, and parts of the Loxahatchee. I'm sorry, I probably answered that before, so I'm sorry about that.
No, that's all right. That was a good point, because I think I totally probably skipped a little bit over that. But yeah, so Vallisneria americana, or American eelgrass, is a native freshwater aquatic grass that's found all through the East Coast and the Midwest, I think, of the US, up as far north as Nova Scotia. So it's found native in our springs. A lot of if you've been hearing about the Crystal River or Kings Bay restoration effort, a lot of that is all American eelgrass. And it is found naturally and native in a lot of our areas. So that's one of the reasons why we selected that as a solution, because I had seen it in some of the areas of our stormwater ditches. And then talking to some of the scientists and biologists, they're like, yes, this is what we would want to go. And then it solved my engineering issue of having to deal with hydrilla, which broke off in long pieces. The American eelgrass will break off only in the leaves, and the root bases can stay in place. And then the leaves generally will only be 12 to maybe 12 inches to maybe 2 feet in length. And then when it reproduces in aerial runners, it'll move downstream on its own and establish, but it's only in mostly smaller pieces versus the other nuisance vegetation that, like hydrilla, that causes issues. So that's where we planted that. And I think the salinity, they can take up to 4 to some of like 8, and then they can take sometimes a little bit more, like, you know, when we have like high tides, we've noticed that an area gets higher salinity, but the eelgrass seems to be doing okay. But there's different varieties that can take different salinity ranges.
Thank you. And Camila Perez would like a clarification on the plant names. Was Vallisneria the only grass that you planted, or was there another SAV species?
So we, in our 2020 planting, Vallisneria was the only species that we planted. We did a planting in May of 2022 in the Salerno Creek stormwater retrofit in the outfall there. And that's the location where we have a much higher salinity gradient, because we checked that. So we have salt water in there. So we planted Rupia maritima in that location, as well as a more salt tolerant Vallisneria. And we're going to be looking at that to see which, how well they establish and which one seems to do better.
Great, thank you. And Michael Walther asks, what is the life of SAV to assimilate nutrients, and what are the long-term maintenance requirements?
So something that I found interesting kind of when researching this and looking at it and talking to people is, generally stormwater features have what's called like a littoral planting shelf. So the plants that are perceived to remove nutrients from the stormwater body get that from the soil, so that we have to wait for the water to deposit the nutrients, and then the plants can pick it up. But submerged aquatic vegetation has the ability to pull nutrients directly from the water column, which seems like that's what we want in Florida, is to get it as fast as we can, and then let that clean water go. So the eelgrass has the ability to pull nutrients from either poor soil. When there's poor soil, they can get it from the water column as well. One thing that submerged aquatics can do is it creates a lot of surface area for microbes that consume nutrients to live and reside. So I think, just in my more qualitative look at it, that's what I think is something that's really important, because when it's looked at littorals, they look at creating that surface area submerged aquatics have they're submerged entirely. And I think the eelgrass really provides a lot of area. And then that, those microbes can consume that nutrients and deposit it in a waste at something a little heavier than the nutrients themselves. And things can consume that, deposit it in something heavier. And actually there was a water ambassador about clams that I thought was pretty interesting, how they filtered the water and then deposited it in something that'll remain settled instead of free floating in the water. And I think the eelgrass has the ability to do that. As far as long-term maintenance, so we're looking at that really closely with ours. It seems that early on in the establishment of a project, maintenance is actually really important. We just kind of watched it for the first year and ended up having to die off because the hydrilla grew vertical and then shaded out the eelgrass, and we had to die off. So we had to initiate a maintenance protocol to mechanically remove all the hydrilla with a 6-foot buffer around our eelgrass. And then that allowed the eelgrass to go. And then occasionally we get hydrilla popping up in between. But when we do, currently we have quarterly, a maintenance contractor will come out with a potato rake and they'll manually remove that hydrilla. But people like myself, we have a couple of other volunteers that will go out to the site, and if they see a hydrilla, they'll grab a potato rake and pull it out. So I think that little bit of work, because it's really easy to identify it, the one thing that doesn't look like eelgrass in the middle, we can pull it out really easily and do that maintenance that way. And we think that as the eelgrass bed gets established more, that the maintenance will actually go down. But right now we're looking at about 80 hours annually to maintain the hydrilla and things like that that would compete with the eelgrass.
Great. And Beth asks if this is the same SAV that manatees eat.
Yes, it is.
Okay. And Lucy lives in Palm Beach County and would like to know if do you know of any similar projects south?
I don't know of it. The only other one that I know that's kind of similar is there's one up in St. Lucie County. I'm thinking Moores Creek or something like that, that they just did something about a year ago, relatively similar, where they planted a stormwater outfall with grass.
That's correct, Nick. In Moores Creek and Fort Pierce, they have Sea and Shoreline, which is the private company that's providing a lot of this plant stock, has done plantings in Moores Creek. The issue that makes it a bit challenging is grazing. And I'm wondering if that's also been an issue for your project as well, Nick.
Yeah, so we noticed definitely the grazing, like I touched on, but very briefly, the predation was a major factor, everything from ducks, turtles, all of that. One of the things that I noticed when we did our project was obviously first in the fastest moving waters where it established the best right away, because ducks and turtles weren't able to sit on it. Then after about a year or so, we started seeing it more right at the outfall control structure where things were moving again. And then we started looking for it more. So I would go into the muck and wave my hand in there, and it would feel like what I call like a buzzed haircut. You wouldn't be able to see it looking in the water, but the bottom was covered in root masses and trimmed white leaves, because the turtles would come in and in essence mow it down, and you wouldn't even be able to know it's there because they're having their way with it. But after about another year, then the planting area was able to sustain the predation, and we would go downstream and see signs of predation, but then right at our control structure and downstream of there was just huge, large mats of eelgrass. So I think, watching that and maintaining that, and we were doing it in kind of small areas, so the predation isn't as significant as you might get in a much larger water body, such as a restoration effort in, say, Crystal River or Moores Creek. And that's one of the things that I think is really neat about this project and concept, is we can put it on, a small scale, or it can be scaled up as well. But this small scale will actually propagate downstream. So once it's able to sustain itself here, we can move downstream. And our hope is that this eelgrass and Rupia maritima will also get established, and then we'll create a seeding bed to populate downstream if we ever do have die-offs and things like that. Because the water body for, like if you have the Indian River Lagoon is one water body. We have 55 separate drainage basins in Martin County. If we have one of these in each one of them, then we could possibly have 55 seeding sources that are in a separate water. So if there's a disease or something like that, we may not see that, and then the seed bank can still, still propagate. And also, I think there's a potential for blue carbon and carbon sequestration that's not even really being looked at. That's just one of the, if there's another reason to make it a good project.
Thank you. Octavio, who I should acknowledge is a water ambassador speaker, asks, can you suggest methods to mitigate impurities from reaching open water on developed lands, such as marinas during storm conditions?
So let's see. On developed land, or so a marina would be separate from a developed land. I would think, because it'd be land, but in general, like a marina. So one thing that we've kind of seen, it's not really a marina, but in a lot of like communities, eelgrass will establish naturally in the lakes, but due to the aesthetics, they'll see it and want to kill it because it touches the surface of the water. Lake management companies commonly kill it. So there's people that live in communities that have thriving eelgrass lakes that probably don't realize it because it's kept at bay due to aesthetics. That's one thing that I think on developed land like that could be evaluated. Because marinas might have the same thing where grasses or things like that might be an impediment to the boats moving through there for aesthetics. So we're kind of doing it in our area where we're treating an area that people aren't looking at it, and ultimately it's our own asset, so we can maintain it for aesthetics as long as it meets the function of water quality and flood control. But putting things like this and other BMPs is important.
Thank you.
Lisa, I've got one more question from the audience.
Yes, please.
The question was, where this person lives, the bottom is very mucky. It's in North River Shores in that general area. And the question was, how can this species, I guess the Vallisneria, can it establish in a very mucky bottom? And how, what's the depth requirements if it's like how deep can it go for sunlight to reach it?
This actually goes well with a question that Lucy has, is whether or not this could benefit water quality in stormwater lakes in large housing communities. So if you can address maybe both of those questions at the same time, Nick.
Yeah, absolutely. So I think I just touched on like large housing communities that, so I would urge everyone to get involved with, if you have a lake in your housing community, communicate with the HOA and see what they're doing for maintenance and what are their maintenance practices. Getting involved, because those lakes play a critical factor. All of those community lakes all drain into what's called a municipal stormwater system, most of them. And then we have to treat that as well. So the cleaner water comes into our system, the easier it is to clean everything through. So that is important to get involved and see how those lakes are being managed. Because I'm talking to lake management folks, their general attitude is, someone told me they didn't like how it looked, kill it. But we're trying to bridge that gap and communicate why it's a good idea. So now as it relates to North River Shores and the like mucky bottom, so with the plugs that we planted, and this is all kind of regurgitate stuff that I got from our environmental consultants, but with the plugs, when they're planted, they'll establish and they'll stay in place best when it's sand. So your likelihood of a successful planting are increased with sand over muck, but once they're established, I think they'll root into the muck and kind of hold it down, which is the goal. With the turbidity of the water or the clarity, that is a major factor, I think, in talking to people with all seagrass, even the Indian River Lagoon and other areas of the state, is water clarity. Here we're planting it, and that's, I think, one of the beauties of the stormwater is we're planting it in pretty shallow water, and generally it's pretty clear, so sunlight can get to it relatively easily. So we're seeing it pretty thick and 2, maybe 3 feet. I don't think I've seen it any deeper than 3 feet. But at that point, the water, that's about as far as I think it's getting real thick sunlight. I think eelgrass, once it can clear the water, and we've seen, and that's one thing that I would like to do more of, is turbidity monitoring on these small project sites, because looking at it, we've looked at upstream and you see a lot of particulate in the water. Just visually, qualitatively, downstream of the eelgrass, it's a lot clearer. So once you get more of a project site established, I think it'll only help that grass recruit deeper and deeper and deeper as the water gets cleaner and clearer. But I think salinity, visible light, and the clarity of the water is a major factor in how well this can be established.
Thanks, Nick. And with that, I'm going to do a shameless plug for our next Water Ambassador webinar, which is September 13th. And that's on the FWC seagrass restoration projects that are being funded as a result of the manatee unusual mortality event. So you'll learn more about sort of some of the seagrass restoration projects that are being conducted in that. Vincent, did you have another question?
Yeah, there's one more.
I can shout out. I'm wondering about, it's kind of similar, but much about I'm living on lake, Cypress Lakes, right? And water level varies.
Yeah.
Right?
Right.
And so, I mean, is there anything that like citizen here can plan that would help, that even if I, don't go to the HOA?
So the question was, we have a person here who lives in Pinecrest Lakes, and your water body, is that a pond? It's a large, she lives in an HOA with a large pond. And so what she's asking is, what can she do to improve the water quality in that pond? Is this something that what you presented today, Nick, is this something that she can do?
And I'm going to also add to that, because we have a similar question in the chat, asking whether or not plantings in the littoral zone, if those can be beneficial in those stormwater ponds.
Yeah, plantings in the littoral zone are absolutely beneficial. One of the, and kind of how I see it, one of the big benefits of that is it'll catch sediment and everything that's running off land into that water.
Sorry, Nick, I'm going to interrupt you real quick. Would you just define littoral zone?
Okay, so a littoral zone would be the shallow shoreline of a stormwater lake. So when lakes or communities are built, they're usually designed with a very flat shelf right at the beginning of the lake, so that it can be planted with, trying to think of some of that. I got alligator flag, bulrush, some of those, I'm not sure the scientific name, but a lot of freshwater wetland plants that you would typically see, pickerel weed with the purple flowers. And those are planted in the littoral areas. Sometimes they'll do grasses and stuff like that too. So those are beneficial because they're going to create more habitat for animals, and then surface area for microbes to eat, and then they'll block that sediment from getting down into the lake, which then can cause the turbidity and the cloudy water, which will impact submerged aquatics. But around a lake doing that, I would definitely get involved. So Pinecrest Lakes, I'm familiar with that. The lakes there are all managed by the HOA, and the pipes from the roads to the lakes are managed by the HOA as well. But getting involved in how those lakes are managed is one way to definitely know more and see. But something like this could absolutely help with that lakes, but littoral plantings as well help. One thing that it kind of, to me, like as a stormwater manager, I get to see, all sides of people that are, environmentally concerned about issues like this, and ones that aren't. Is people in some communities will fight against littoral planting areas because they house snakes and turtles and things like that. So just be aware of that and increase the education with all your neighbors that, yes, that's part of the neighborhood we live in Florida here.
Thank you. So it is 1 o'clock and I want to thank everyone for participating. We do have a bunch of other questions in the chat. Nick, I don't know if you have time, if those who want to stay on, if you're able to address those questions. Otherwise, we could ask that you address them and we can email them out. I don't know.
Yeah, I have a couple of minutes if that's fine.
Okay, perfect. So those of you who have to leave, thank you so much for joining us, and we hope to see you in September for our penultimate webinar for 2022. The next question is by Judy Orca, who asks, if shoreline vegetation is treated with herbicides, would that kill the eelgrass?
So as I've learned through some of this, talking to people in the lake management industry, there's a big difference between herbicides that treat submerged aquatic plants and ones that treat plants on land. It's like glyphosate, for example, on land. How we've seen it, I can guarantee in a 3,000 urban acre basin, some of that is getting into our stormwater ditches. We've not seen any die off in our area that we could relate to a poor water quality boom due to that. Because I know there are areas that are treated with herbicides on the shoreline vegetation or upland vegetation. So currently, I don't think that really has that much of an effect on our submerged, because the mechanisms of a submerged aquatic herbicide are a bit different than one that you would spray on land. So when it's in the water, it's got to do certain things to be able to settle enough to cause damage. But water generally dilutes things really well. So I'm not seeing it. I'm not worried about it personally as a huge impact to us in our project site. And where we did this first one is in a just over 3,000 acre urban basin known as the Coral Gardens Basin, which stretches back to Cove Road and all the way up to Coral Gardens, Willoughby community, and everything like that are within this basin.
Great, thank you. And Lucy asks again, oh, sorry, Vincent, what?
And Nick, if I may, just for the interest of time, we did have the second part of that last question that was asked is, and it relates to not only her question, but the earlier question on the chat, is working with your HOAs to try to do a project like this. And Nick, if you touched upon perceptions, at least within the professional community and a little bit in the lake management community, and with some resident perceptions. Could you comment on that? Because I feel that's going to be a major, that can be a major barrier to trying to do this work on this project from a pun intended, grassroots level.
If I can maybe cut in there, University of Florida has done quite a lot of work working with HOAs and local communities and doing sort of survey work and social marketing work to do exactly that, evaluate perceptions of residents in HOAs and then create marketing tools to address those misconceptions or misperceptions about littoral zone plantings and stormwater ponds and treatment. So there's resources out there through UF that we can definitely help. And then Nick, from your personal experience, if you want to add anything, that would be great.
Yeah, no, I think you nailed it. You got to, look at, all the resources that are available to help communicate that and the reasons why it should be done. And then doing it in a tactful manner, like approaching the HOA and just understanding that there are people that, may not be familiar with the wildlife that, also call Florida its home. So we just have to be aware of that and then, work to communicate. But oftentimes we find that communication can can really be one of the hardest aspects of any project. So that's definitely always a challenge, but looking at everybody's point of view and addressing those concerns will help you get successful.
Okay. So we have two last questions. Lucy, who I should also acknowledge was a water ambassador presenter. Sorry for not acknowledging that previously, Lucy. But she asked about, do you worry about the lack of biodiversity by planting only eelgrass? Should other native plants be included?
No, so I think that's a great question. So we have thought a little bit about it, and some of the recommendations, actually talking with FWC about it a while back, where when we have the nursery grown ones, to actually try to get some of the native ones parsed in there as well. We haven't done that yet, but that's something that we're looking to try to do. But there are also many other types of naturally occurring submerged aquatics that we're starting to evaluate, and we found a little bit of research on. I'm trying to remember the names of some of them, but they'll grow with the eelgrass. And we generally, because we've changed our maintenance practice in that area, they're continuing to grow with the eelgrass, and we're not removing those or treating them. So we have a decent bit of biodiversity in the area as it relates to different plant species. And then different things will, like in Florida, a lot of things grow. So we'll just see new plants accumulating within our eelgrass area. And unless it's one of the species that causes us issues to actually outcompete the eelgrass, like the hydrilla, we've been currently leaving it, but we're kind of monitoring and watching those.
Okay, and the last question from Christian Wagley is there any benefit to trimming the SAV and removing that in order to help remove the captured nutrients from the system?
Yeah, I think absolutely. That's something that DEP does allow for in their BMAP, or best practices is nutrient removal credits based on harvesting. So harvesting is generally kind of expensive to go out and collect this stuff. So it's really not done too often here, but that is a valuable means. And eelgrass itself will, when you get a cold period, it'll actually shed, or if it gets too long or too thick, it'll shed itself downstream, and that's where it can then propagate or decompose as a heavier material, or get eaten by manatees downstream, which is one of our goals that hopefully it does. Because I've heard that in some of the other lakes in Martin County that do have eelgrass, where they outfall a couple of times a year, the grass will die off and split off in individual blades, and that'll come floating through a canal, but then has a high likelihood of the manatees eating it as it floats by. Because that's usually in the winter time when you get a little bit of a cold spell, and then the grass will shed a little bit to save energy.
Great. Well, that's it for the questions in the chat. We've got a lot of thanks and great project and presentation. I know on behalf of Vincent, myself, and the Water Ambassador Program, we're really looking forward to working with you, hopefully getting some volunteers out there to some of these sites to help either with maintenance or plantings in the future. So thanks for an awesome presentation, and thank you everyone for joining us live or virtually. And we hope to see you in September. Thank you.
All right, thank you guys very much.
Thanks, Nick, and thanks everybody for joining us. I do, most people left live here, but I do wanted to ask everybody that is here, we do have a paper version of the evaluation poll that Lisa displayed earlier online, if you wouldn't mind filling that out. Cool. Yeah, thanks, Nick. That was fantastic.
Yeah, anytime.
So